Welcome, ladies and gentlemen. So what I'd like to do is show you how to determine all of the possible rational zeros by using the rational zero test. So basically, this is a rule that's going to be very helpful when we're determining all of the zeros. However, it doesn't tell us all of the zeros. It just tells us if we have rational zeros as zeros, it's going to be one of the ones that we're going to go ahead and write down. So what it's basically doing is it's giving us a set of zeros that could possibly be zeros to our solution. So, we've learned how to, find solutions, find the zeros by, factoring, or when we're maybe given a solution and so forth. But if we're not given a solution, we're not given a zero or a root or a factor, we kind of are stuck out of luck. We can always go back to graphing, which is the preferred method. But even on graphing, sometimes we might not be able to find exactly where it crosses. So looking for the solution set of your rational zeros is going to be very helpful in further problems where we have to find all the solutions and we're only given the polynomial. So anyways, remember there's multiple different, not all zeros are going to be rational. We could have irrational real zeros, and we could also have imaginary zeros. So these are just going to be the rational zeros. But there's two other zeros that we'll talk about, which we'll get into later. All right. So first of all, to find all the rational zeros, basically there's two values that we're going to look at. We're going to look at our coefficient of our leading term, as well as our constant. Now you want to make sure when you're doing the rational zero test that you have your polynomial in descending order, meaning the degree or the term with the largest power is going to be first, and then going down in descending order. Then what we do is we label P and Q. So P is going to be your constant, and Q is going to be your coefficient. Now, what the rational zero test basically tells us is the set of rational zeros is going to be plus or minus all of the factors of P over all of the factors of Q. So it's basically plus or minus P over Q. And this is going to be the factors of P over Q. So basically, what I like to do is write out, first of all the factors of P, and then divide it by all the factors of Q, and then go ahead and write them out as one. So basically, I have plus or minus the factors of 4. Don't worry about negative, because it's plus or minus. So the factors of 4 are 4, 2, and 1. The factors of Q is just 1. Now, basically, what I'm going to do is I'm going to rewrite for every single solution. So my P over Q plus or minus is going to equal plus or minus 4, comma, plus or minus 2, comma, plus or minus 1. That means if I have a rational zero, if I have a zero that is rational, it is either going to be plus or minus 1, plus or minus 2, or plus or minus 4. And that'll be very helpful. I'll show you in another video why this test can be useful. But basically, right now, we're just trying to determine all of the rational zeros. So in this case, I always like to just label them P over Q. Again, we have 1. And again, it's just very helpful just to write in it, just a small little extra step. So if I have plus or minus P over Q, again, I like to write all the factors first so I don't forget one. 8, 4, 2, and 1. And then again, all over 1. So my rational zeros is going to equal plus or minus 8, comma, plus or minus 4, comma, plus or minus 2, comma, plus or minus 1. Now, obviously, ladies and gentlemen, you could write plus 8, negative 8. But I think it's just easier just to write plus or minus. Or you could also even write, another way to do this is plus or minus on the outside, and then go ahead and list the factors. That's also acceptable form. All right, so now let's get into a couple where we have, some numbers other than 1 for our coefficient. So we have P over Q. Again, just simply take P over Q. Again, we're looking at the factors. So we're going to take all the factors of 6, which is 6, 3, 2, and 1. And then all over the factors of 3, which is 3 and 1. OK? So now, basically, when you have two different factors, what we're going to do is we're going to do all the factors of 3. And what I like to do is I like to write them all out first, and then take out the duplicates. All right? And once you kind of get used to this over and over, you can start taking out the duplicates as you write it. But for this kind of instructional video, I'm going to write everything out first. So I'm going to do 6 over 3, comma, 3 over 3, comma, 2 over 3, comma, 1 over 3, comma. And then we have 6 over 1, which is just going to be 6. 3 over 1, which is just 3, 2 over 1, which is just 2, and 1 over 1, which is just 1. Now let's go and simplify. Well, 6 divided by 3 is 2. I already have a 2, right? So that's a duplicate. 3 divided by 3 is 1. I already have a 1, so that's a duplicate. And then the rest of these will work. So my plus or minus p over q. You can write these in descending or ascending form or ascending ways, especially when you have a lot. I think that's a really good idea. I'm not going to do that just because I don't want to. But it is a good idea, especially like on a test or so forth. You'll see them in ascending, descending order, or your teacher might ask to make sure they're in ascending or descending form. Oops. So I got a little lazy here. So plus or minus p over q equals, let's do plus or minus. I forgot to put the plus or minus, so I'm going to put it outside parentheses. OK, in the last example here, now our q is larger than our p, but that is perfectly fine. Again, we're just going to take all the factors of our p and our q, and we're just going to list them out. So our factors of 4 are 4, 2, and 1. And our factors of q are going to be 6, 3, 2, and 1. Now, I have a little bit more factors here, so I'm not going to write everything out like I did. As I kind of get through it, I am going to, as I kind of get over to it, I am going to simplify them. So let's do divided by 6. So 4 divided by 6, actually, let's write them out. I don't want to confuse people. 2 over 6, 1 over 6. Then we do 3s. 4 over 3, 2 over 3, 1 over 3. Then we do the 2s. 4 over 2, 2 over 2, 1 over 2. I'm not going to write 1 as a denominator because I didn't do it over here. Hopefully you understand that whenever you divide by 1, you're just going to be left with 4, 2, and 1. 4, 2, and 1. OK, so now let's go and simplify these. So it's plus or minus p over q equals, let's see, 4/3 reduces to 2/3. Which we already have, so that's a duplicate. 2 over 6 divides to 1/3, so we already have that, so that's a duplicate. So my first solution is 1 over 6, which I do not have, so it's plus or minus 1 over 6, comma, we go to 4/3, that's unique. Then we go to 2/3. Then we have 2/3, sorry, then we go to 1/3. Then we have 4 over 2, which is the same thing as 2, which is a duplicate. 2 over 2, which is the same thing as 1, which is a duplicate. Then we're left, dang it. All right, I'm going to put these again in parentheses. Then we have 1/2, comma, 4, 2, and 1. So there you go. So there you go, ladies and gentlemen. That is how you use the rational zero test to determine all of your rational zeros of a polynomial. Thanks.